Assalamu alaikum everyone. So today we will be having our lecture number 32 and the topic is wireless local area network and the underlying technologies that are being used in wireless LANs. So before starting, let's have a brief introduction of wireless LANs. Actually, in addition to the wired network, the laptops, the mobile gadgets, PDAs and cell phones, they have a huge demand for wireless local area network so that they are able to access the services, all the services that they are using onto the LAN. So they want to move around, they want to move from one office to another office, and they alongside their mobility, they want to access those services. So this is the requirement number one. And then of course if we want to lay the wired infrastructure, so of course obviously we need to lay the cables, we need to connect different connectors, and we need certain media termination devices. So this can be avoided if we have the wireless infrastructure. And nowadays we know that the wireless infrastructure, it's very cheap, and its data rate is rising. So it's, you can also compare to some of the extent to the existing LANs, right? So as a result, there was a huge requirement for the wireless technology so that the people can move around and they can access different services. So they don't have to lay the wired infrastructure, so they can save a lot of money because when we have wired infrastructure, so we have to manage it. We have some sort of administration that is going to manage the services. So in case of wireless infrastructure, we can save a lot of our money. So as a result, due to this huge demand, a lot of companies, they actually started developing different wireless products. But the problem was that they were incompatible with each other. So for example, if I have an access point from one company and I want another device that should be connecting or that should be communicating with that access point, so there is the problem of compatibility. So that was a big problem because we don't want to stick ourselves to a single vendor. So as a result, the industry decided to entrust standardization, right? And IEEE was the first who took the initiative, and they constructed, or they launched IEEE 802.802 committee. Then we should define our LAN, WLAN properly. So obviously there should be some difference. It's a communication infrastructure that provide connectivity to wireless devices within a given area, right? So this is one of the limitations, that we have very small geographical area that we can have. So Wi-Fi is the universal standard that is being used in WLANs for wireless network and the wireless equipment of wired Ethernet networks, right? If we talk about the office, Wi-Fi networks are adjunct to the wired network. So you can say that we have the wired network, okay, and that wired network is actually the main stream or the main core, right, where most of the services, most of our servers, they are being placed, because we have the wired infrastructure over there. We have the high speed data links that are required in order to connect all those servers together. So we have a wired network, wired infrastructure at the core, and then over that core we can build the wireless infrastructure. So our services are being hosted on a wired network, and we can have access point that is connected to that wired network, or maybe some other devices that are connected to the wired network in order to provide all the services. So if we talk about a home, a Wi-Fi network can serve as the only network. We have Wi-Fi networks at our homes, since all laptops and printers, because nowadays we have printers that can be connected by using this Wi-Fi standard, can serve as the only network, since all the laptops and many printers come with Wi-Fi built in, right? And Wi-Fi can be added to the desktop computer. We can also have, if my laptop, my computer, it don't have the Wi-Fi interface, so I can buy a Wi-Fi dongle, that is a USB based device, or maybe if I have a personal computer, so there are certain PCI slot cards, so I can use that card, and then my system should have the capability, or will be having the capability of Wi-Fi access. So Wi-Fi is achieved with a wireless base station that is called the access point. So obviously we need antennas. They transmit and receive at certain radio frequency, and the range of the access of the, or you can say the area, is from 30 to 150 feet through walls and other non-metal barriers. Then there are certain design goals whenever we talk about the wireless design, wireless LAN. So we want global seamless operation. So if I'm moving around, I'm moving from one office to another office within a building, or maybe within a home, from one room to another room. So I want seamless access of the services, right? And then of course, if I have a laptop, I have a cell phone, or maybe some PDA or some other gadget, so it has a limited battery power, right? So the access technology should be power efficient. The routing protocol should be power efficient. So this is another design goal whenever we talk about the technologies. And one of the more interesting point is that no special permissions are required in order to have the frequency band, right? So, and then of course it's robust transmission technology, and we have simplified spontaneous cooperation at meetings. For example, if I have to attend a meeting at a certain point, so it's very difficult to provide a wired cable to each participant. So what we can have, if we have the wireless infrastructure, so we just have to mention, for example, for security reasons, the password and the network name, and that's it. And the people, they can access the network, they can access the services over this LAN. And then of course it's very easy to use as opposed to the wired infrastructure or wired interfaces. So you just have to turn on your interface, and then you will be able, after some of the configuration, you will be able to access the infrastructure or access the services. And then the management is very easy. If I have to manage, for example, a wired network that is maybe 50 nodes or 100 nodes, so I have to have a system administrator. But if I have the wireless infrastructure, so there are access points and maybe some of the servers, so it's rather easier to manage that infrastructure, because the access points nowadays, they are plug and play. You just have to put the power and put the cable so that you are able to connect your existing wire network infrastructure. So management is easy, right, as opposed to the wired infrastructure. And then we have the cost factor also when we talk about the design goal, security, right? So privacy should be able to collect user profiles. So this is also one of the key design goal which we have to keep in mind when we are talking about the or designing some of the wireless LAN infrastructure. So because you are in the air and your data can be captured, or maybe some eavesdropper can access you. Then transparency concerning applications and higher layer protocols, but also location awareness if necessary. So these are some of the design goals when we talk about wireless LAN technologies. So as mentioned that when there were a huge requirement for wireless technology, so there are a lot of vendors who jumped into this domain, and they were having their own standards. So there were the problems for compatibility, for standardization. So many standards were there in the market. So if there are many standards, so it means no standards, because there was no compatibility. They cannot connect. They are not able to connect with each other and communicate with each other. So another point is that they have the limited or no encryption. That is a big issue as a security point of view, right? So everyone want its security, personalization. So that was the big issue, that they don't have encryption, or if some of them have encryption, that is the limited up to certain limits. And the data rate, that is also one of the big issue, that if I have to download a huge amount of data, so if I have the lower data rate, so I will be preferring the fixed network. So the data rate or the throughput was 0.5 to 2 megabit per second. The cost, that is another important factor, that was also on the higher side for the interfaces, for example, onto the laptop, onto the PDA, onto the cell phone. So that was, the cost was also on the higher side. And again, the access point, and by using those different access points, we normally access those wireless infrastructure. So again, the cost for access point is also on the higher side. And limited roaming, so you cannot roam about freely, so you have to stick yourself to a particular location in order to access the wireless LAN. Then if we talk about the modern wireless LANs, or you can say the advanced wireless LANs, so as the IEEE took the initiative and they launched a group named IEEE 802 group, and as a result we have this standardization, right? So as a result of this standardization, now the industry, they follow those protocols, those rules, in order to launch their products, in order to develop their products, or in order to design and market their products. And the encryption was improved. 128-bit encryption was launched, and the throughput, data rate, is also improved, and they have more throughput. Nowadays it is more than 11 megabit per second, and the cost was also reduced because they were following a certain standard. So every vendor was following the standard. They have the same product with some differences. So of course, as a result, the cost is reduced for interfacing, right? And the cost is also reduced for access points. And now they have the integrated roaming, because due to the result of the standardization and different design procedures improvement. So in addition to its advantages, we have also disadvantages as well as whenever we talk about wireless infrastructure. So here are some of the advantages. So very flexible within the reception area, and we can have ad hoc networks without previous planning possible, because if we want to operate the wireless infrastructure with the access point, right? So we are actually relying on those access points or maybe the core network, that is the wired network. But in case of ad hoc networks, there is no requirement for the access point. So the gadgets or the computers or maybe the laptops or some other devices that are part of the wireless LAN, they build their network on the fly, and they are taking the responsibilities of all the management. But remember that we have to choose or we have to rely on certain protocol. So no wiring difficulties, as mentioned, that if we want to lay a wired infrastructure, so of course we have to lay down the cables, connectors, we have to terminate certain devices. So it can be a difficult task depending upon the infrastructure of the building. Firewalls, so we need firewalls in order to secure our LAN, our fixed network more. So that is also go into the advantage for wireless LAN. And then more robust against disaster sort of situation. So if we have fixed infrastructure, right, so that fixed infrastructure obviously has to be in a building or maybe in a college or university or hospital. So during the emergency situations, so if there is a flood or maybe there is an earthquake, so as a result, most of the time the buildings, the colleges, the schools, all the building infrastructure is being hit mostly, right? So in that scenario, obviously it's very obvious that our wired infrastructure will be damaged also. So if we have the wireless infrastructure, right, so we can reconstruct it in case it is also damaged. We can reconstruct very quickly, right, because we don't have to lay the cables, we don't have to lay the connectors, we don't have to terminate the equipment, right? So this is also one of the advantage, that more robust against disasters, for example earthquakes, fire, users pulling or plug, right? And then here are some of the disadvantages of the underlying wire technologies. Very low bandwidth, we have a very low bandwidth, so as a result we have a very low data rate compared to the wired network due to the shared medium, because we are actually using the shared medium, right? Many proprietary solutions, right, especially for higher bitrate standards, like standards take their time, because after the establishment of IEEE 802 group, they took a lot of time to design different standards for the market. So these sort of things, they take a lot of time because there are a lot of different people that are involved in order to make decisions. Products have to follow many national restrictions, so regulations. If I have to launch a wireless access point, so I have to follow the rules and regulation for that country, for some country, for example. So that rules and regulation, they also go into the disadvantages of the wireless technology, access technologies. If working wireless, it takes a long time to establish global solution. Okay. So here are some of the deployments when we talk about the wireless LAN. Medical professionals, right? So educational institutes and temporarily situations, for example, the emergency situations where we need to lay down the infrastructure very quickly, so we can go for the wireless LAN. Then airlines, right? So nowadays we have the internet access when we are traveling from one point to another point by using some airlines. So some of the airlines, they are providing internet access. So security staff, so this is also important, that the security staff, they don't want to carrying their infrastructure with them all the time. Then emergency centers, right? So these all are the deployment venues for wireless local area network infrastructure. So here are some of the applications. We can extend the existing LAN. So as mentioned, as use case where we have a wired LAN where all these services are accessible, for example, internet, data access, and voice, video, and there are a lot of different services that are being available onto the wired LAN, right? But as we have the wired LAN, so we cannot have the roaming facility. We cannot support the mobility. So in order to do that, what we can do, we can build a wireless infrastructure. So we just have to buy some access points, right? And then we have to configure those access points accordingly, and that's it. Because most of the access points that are available nowadays, they are plug and play. So we just have to plug and then configure them. That's again on the lighter side, and then we are ready to provide at least mobility and roaming, right? And all the services, they will be accessible by those different devices, for example, PDAs, cell phones, or laptops. So we can extend the LANs. And there can be another scenario. For example, if a multinational company or a local company, they are having different buildings. They are far apart, and they want to connect those buildings by using some wireless technology, right? So the distance, of course, matters over here, but we can concatenate different access points so that we can extend the coverage area of the wireless infrastructure. So we can also have cross-building interconnect, and then of course nomadic access. So I have to move around whenever, or my job is to move from one office to another office, or maybe from one building to another building for some purposes, right? So I should be having access of all the services onto the infrastructure. So as a result of the wireless LAN, I will be able to have nomadic access, or it will be supporting mobility. Then ad hoc networking. So if we have the wireless infrastructure, so we can have the ad hoc networking facility over there. So let's talk about in details about the LAN extension, how we can extend our LAN into the wired LAN on same premises. Wired LAN, right? It is acting as a backbone, and it's has to support servers and stationary workstations, right? So wireless LAN stations in large open areas and manufacturing plants, stock exchanges, trading floors, and warehouses. Those are the ideal location for the wireless LANs, right? Okay. So here is the scenario. So you can see we have the wired infrastructure. So this right, this is the, you can say, core, network, and you can see that there is some cable that is going there. So here we can have an access point, right? So again here there is some fixed infrastructure over here, and those different devices, they are wireless. This one, right? And again here we have the wired infrastructure, Ethernet, right? So this is bus topology, and again here we have this access point, and those circles, they actually are access point, and these are the different PDAs or maybe laptops on some other devices. And here again this Ethernet switch is connected with this central access point wirelessly, right? So there is no physical connectivity between this Ethernet switch and this access point. So here we have the core network, and here you can say we can have the wireless infrastructure. Most of the systems and servers and switches, they are connected wirelessly, so though we have some wired infrastructure over here. So you can say, assume that this can be a cable, right, Ethernet cable, right? And here we have extended our LAN, so you can partially say this is a small LAN, right, and this is the core network or core LAN local area network, and here is the extension, right? So you can see this is the extension onto the wired LAN, right? So here and remember that we will be using a single frequency over here. So we can have another scenario, right? So for example, again we have the core network over here. So here all the different cells, if we talk about different segments as, or take different segments as different cells, right? So this is cell 1, right, and this cell is using frequency 1, and this is cell 2, so this cell is using frequency 2, and here we have another cell, this is using frequency 3, right? So you can see there are some of the wired infrastructure termination by using this cable. So you can say that these are the core or central access points, right? And every cell is able to access all the services that are available over this LAN, right? So here we have the Ethernet switch, right, and this is the bridge or router, and this is can be some server, right, hosting some of the services, and again here this looks like a rack mount server. So you can see that we have multiple cell wireless LAN, right? So each cell is using a different frequency, and we have different access points and different nodes, PDAs, laptops accessing the cellular wireless connectivity. So here we have the cross-building interconnect, connect LANs in nearby buildings. So if I have a LAN, right, and I want to connect LAN in one building to another LAN in another building, so we can also use the high data rate wireless connectivity over there. Point-to-point wireless link can also be a choice, right? Devices connected are typically bridges or routers, so we can use different bridges and routers. So the scenario is that we have one building over here, right, and then another building and C and D, right? So and we want to connect those buildings together. So there are different choices. The one choice can be that we have the core network, right, or maybe the core network can be there. It depends upon your topology, upon your configuration. So there are a few choices. We can have the connectivity, cross-building connectivity by using wireless access points, right? So we can have access point over here. So if this is the ultimate area coverage, so I can concatenate the access point over here with this access point, and then I can have an access point over here. So this will be automatically forwarding data to this access point, right? And we can also have the two ports, one for transmission and one for reception on this access points. So in this way we are able to use or connect those buildings. And then we can have another choice, right? We can connect those buildings by using wired technology, and within each building we have the wireless access, right? So all the buildings, they are connected via the backbone, right? That is the wired media, and then we have we have the wireless access. So if one of the user is moving from here to here, so we have to have some sort of special configuration and administration in order to seamless access of the services across those buildings, right? So this can be another use case. So here we have shown some of the devices. So here we have mentioned another use case where the objective is to connect to provide wireless LAN connectivity across the buildings, right? So you can see that we have shown different devices from a specific vendor. So the advantage of those devices is that they can cover larger area. So if you look at here, the configuration of the buildings over here, so they are at a longer distances from each other. So if we look at this building and this building, so the distance is on the higher side, and this building and this building, again the distance is on higher side because there is a lake in between, right? So we can use different devices. We can also concatenate those different access points, right? So maybe the distance is on the higher side, so we can have an access point over here. So it will be much better as opposed to laying the cable between those different buildings, right? So your network will be ready maybe within few hours. So you just have to mount those different devices there, and then as they are plug and play, and after some configuration, your buildings, they will be providing connectivity via a wireless connectivity, right? So point-to-point wireless link is used. So connected are typically bridges or routers. We can also have bridges and routers because those access points, they also act as routers and bridges. So here is the mobility, nomadic access. So link between LAN hub and mobile data terminal equipped with antenna, right? So laptop computer or notepad computer. And there are some of the uses of transfer data from portable computer to the office server. So if my job is to collect data from the customers, and then immediately after collecting the data, I have to transfer to the central office in the company so that the company can take some decisions. So we can have this facility transfer data from portable laptop, gadget, or maybe cell phone, extended environments such as campus. So we can extend the services in our campus in order to provide services to students with limited access, right, around with portable computers. So students can move around and they will be able to access the restricted services and civil services, or access data, restricted data again. Servers on the wired LAN, right? So if we have an infrastructure where core is the wired LAN, and over that core wired LAN, we have the wireless infrastructure. So the servers that are available in the wired LAN, we can access those services by using the wireless access technology. So here is the example of nomadic access, right? So you can see we have library, right? So here is the student union building, and we have the campus over here, right? So you can see that the backbone over here is wired network, right? So this is high 1 giga, 1000 megabit per second, right? And again here giga speed cable over here, and these cables, they are 10 megabit per second, right? So, and these are the wireless access points, right? And these people or students or employees, they can move around, and they will be able to access the services that are actually available within this wired infrastructure. And then we can have the ad-hoc networking over here, right? So the difference is that for wireless LAN network, we need an access point, right? So for ad-hoc networking, we don't need an access point, or the computers, the devices that are part of the network within the wireless LAN, they will be managing, operating at their own, peer-to-peer network set up to meet immediate need, right? So this can also be used in military applications. Group of employees with laptops, right? And they are there for a meeting. Employees link computers in a temporary network for duration of the meeting. So here are some of the requirements for the wireless LAN network or infrastructure: throughput, number of nodes, connection to the backbone LAN. So this is the termination or the connectivity with the backbone LAN or high-speed LAN, and then the service area. That is also one of the key requirements when we talk about the wireless LAN. Battery power consumption, right? So we should have effective and efficient routing algorithms and access technology mechanism so that the battery should be used at the lower side. Transmission robustness, right, and security, and then cooperation, network cooperation, license-free operation. So we don't want to pay for the frequency allocation, or we don't want to involve in the regulations. So there should be some license-free operation regarding the wireless LANs. And then handoff roaming. So in order to, when we are moving from one cell to another cell, so there should be a handoff, right? So it should be the service access should be seamless, right? So when we are moving around, so the service access should be seamless. Dynamic configuration. So let's have more details regarding those different LAN requirements. The MAC protocol should make as efficient use as possible of the wireless medium to maximize the capacity, right? So it means our MAC protocol should be efficient enough to use the maximum throughput, right, by using wireless LAN technologies, right? And then the number of nodes. That is also one of the key aspect and important factor regarding the wireless LAN requirements, because if we have large number of nodes, right, so of course they will be accessing simultaneously. If there is a use case, they are accessing the network simultaneously. So there should be some mechanism to because the medium is shared, right? So we should have some robust and efficient protocol in order to accommodate nodes with good quality of service access, right? So wireless LANs may need to support hundreds of nodes across multiple cells, right? So in each cell we have a large number of nodes. So if we go for the use case where we have a lot of cells, so here if, for example, in each cell we have 50 users, so altogether we will be having 150 users. So there should be some effective mechanism to provide services simultaneously altogether to the 150 users. Then connection to the backbone LAN. In most of the cases, interconnection with stations on a wired backbone LAN is required. So of course, as we can have, so as here you can see that this can be considered as the backbone link, right? Because it is a high-speed link. So most of the people, they has to access data from the library if we are talking about some university or maybe some college. And here again we have the backbone, high-speed backbone link, right? So this is also important, wireless wired connectivity or the termination of the wireless network onto the LAN, right? This is easily accomplished through the use of control modules. So we can use different routers and different bridges, right, that connect to both types of LANs. Because if we have a LAN that is providing, so this can be the use case again here. So this is again the cable that is providing 10 megabit per second, and this again the cable or LAN that is providing 1 gigabit per second. So you can imagine that how we are able to connect it. So this is the issue over here. to accommodate for mobile users and ad-hoc wireless networks. Service area, so of course this is our desire that we should be capable of covering more area, right? Has a diameter of 100 to 300 meter but nowadays we have more coverage area. Then this is very important because whenever we have cell phones, PDAs, laptops, they have limited battery time. So power consumption or the mechanisms, the access mechanisms and the routing protocols, they should be power efficient. Use battery powered workstations that need to have a long battery life and use with wireless adapters, right? This suggests that a MAC protocol that requires mobile nodes to monitor access, because if we are in a wireless environment or Wi-Fi, we are using Wi-Fi. So after every predefined amount of time, there is a dialogue between the access point and your PDA or maybe cell phone or maybe laptop. So there should be some mechanism to save the power over there. Then transmission, robustness and security. Properly designed wireless LAN may be interference prone and easily can be tapped, right? So the eavesdroppers, for eavesdropper, wireless LAN can be a soft target. Design of a wireless LAN must permit reliable transmission even in a noisy environment, right? So as we have to rely on the free space, right? So there should be some mechanism in order to ensure that we are getting the data without errors and with security. So network operations, LANs become more popular. It's quite likely that 2 or more wireless LANs will operate in same area or in some area where interference between the LANs is possible. So this can be the case. So that's why we mentioned that one frequency in one cell, another frequency in another cell may cause the interference, right? Normal operation of the MAC algorithm, right? So there can be some problems and may allow unauthorized access to a particular LAN. License-free operation, so we don't want to pay for the frequency usage, so there should be frequency allocation, frequency band that is not come under the regulation, right? And then handoff, so of course we want seamless access to the services when we are moving around. So if I have to move from one cell to another cell, so there should be some mechanism, for example MAT protocol, that should have the capability to perform the handoff from one cell to another cell, right? Like we talked about the handoff in GSM network, GSM environment. Then dynamic configuration. So the addressing scheme, MAC addressing scheme, and the network management aspects of the LAN should permit dynamic and automated addition, deletion, and relocation of end systems, right, without disruption of the ongoing services. So we should have the capability to add different interfaces, to remove different interfaces, to block different interfaces, and that should be done without interruption. So it is not possible to first stop all the services, and we have to perform certain or apply certain policies onto the existing wireless LAN. So here we have some of the wireless LAN classifications. So we have infrared LANs, IR, SPED spectrum LANs, the LANs, wireless LANs that are using SPED spectrum technology, narrowband, right, microwave category, or okay. So here we have mentioned those different SPED spectrum wireless LANs mostly operate in ISM, industrial, scientific, and medical band, ISM band. No Federal Communications Commission licensing. So if we talk about USA, so no, we don't have to pay for the frequency. If we talk about the OFDM, that falls in narrowband microwave. So they use orthogonal frequency division multiplexing, these narrowband microwaves, and superior to spread spectrum, right? So they perform better as opposed to spread spectrum. So the frequency range is, it started from 2.4 gigahertz and it goes up to 5 gigahertz, right? We talk about the infrared WLANs, individual cell of IR LAN limited to single room, and if we talk about light, right? So there is some sort of interference when we talk about the infrared. So there is some problem that it cannot penetrate through opaque walls. So here are some of the advantages of infrared over microwave. So spectrum for infrared virtually unlimited, right? So because we don't have to pay, and the spectrum is bigger, on the bigger side, or the frequency band is on the larger side. Infrared spectrum unregulated, so again we have the advantage over here, we don't have to pay. Equipment inexpensive and simple, so we can think about the remote control that is using the infrared technology, and reflected by light colored objects, right? Ceiling reflection or entire room coverage. And then it does not penetrate walls, right? More easily secured against eavesdroppers, right? So that is the advantage as well as the disadvantage. Then here are some of the disadvantages. So we can use the infrared technology only in indoor environments, right? Sunlight and indoor lighting, right? Ambient radiation appear as noise, so that is the interference. In infrared, transmitters of high power required, so we need high power in order to have transmission from one point, right? And there is a very short range for the access when we talk about infrared. So here are some of the techniques that are being used by infrared data transmission, right? Direct beam infrared, so omnidirectional and diffuse. So direct beam, you can take the example or you think about the remote control, right? Okay. Used to create point-to-point link, so we should have line of sight communication. Range depends on emitted power, what is the power of emission, and the angle, right? Focused IR data link can have range of kilometers, right? So, and cross-building interconnect between bridges or routers. So again, the data rate is on the higher side, right? So if we have a focused infrared beam, so we can access to longer areas, longer distances. Omnidirectional base station, we have a single base station, and that base station will be radiating data all around, right? Omnidirectional. Line of sight of all other stations on LAN. Station typically mounted on a ceiling, right? Base station acts as a multi-port repeater. And then diffuse. Focused and aimed at a point on diffusely reflecting ceiling. Infrared radiation strikes ceiling, redirected omnidirectionally, picked up by all the receivers. So this is the diffuse technology regarding infrared. So here is the spectrum wireless LAN configuration, multiple cell arrangements. Adjacent cells use different center frequencies, so every cell is using different frequency. We can have the configuration of hub connected to wired LAN, stations on wired LAN, and in other cells may do automatic handoff. So this is a plus for spectrum, peer-to-peer, no hub, right? So we have two configuration when we have a hub and when we have a peer-to-peer configuration. MAC algorithms such as CSMA used to control access for ad hoc LANs. So this peer-to-peer configuration is used for ad hoc LANs. So here are some of the features of the spectrum WLANs, different between within different countries, right? So very low power, it uses very low power. So this is again because the idea over here is we actually the signal has a high power before. After the spread spectrum, we have the frequency band on the higher side, but the power is lower, and the signal is actually hidden within the noise floor. So this is very secure technology when we talk about the jamming and eavesdropping, right? So that is one of the key point over here when we talk about spectrum WLANs. Okay, these are the bands that are allocated. You can see 902 to 928 megahertz, right? So then we have band in gigahertz, right? And then we have different allocations in Europe and Japan as well. Interference, many devices around 900 megahertz, cordless telephone, wireless microphones. So this is the frequency area where a lot of other devices, they are actually functioning: cordless phones, wireless microphones, and amateur radio, right? So we have to avoid the interference. We can use other frequency bands accordingly if we are in a certain country. Narrowband microwave LANs, radio frequency band for single transmission, relatively narrow band, licensed. It again have both the licensed and the unlicensed frequency bands. So it depends on the regulation where you are going to use. You have to pay, or maybe you don't have to pay. Then licensed narrowband RF, specific geographic areas to avoid potential interference. Okay, so here is some of the vendors that are using unlicensed narrowband RF, right? Radio LAN introduced narrowband wireless LAN in 1995. Unlicensed ISM spectrum. Low power, again the power as within the SPED spectrum, lower side, 10 megabit per second, and the range is 50 meter to 100 meter. So here we have mentioned the technology, access technology that is being used for wireless LANs. Physical layer, direct sequence SPED spectrum, 2.4 gigahertz ISM band is used, and the data rate is 1 megabit to 2 megabit. And we have 7 channels over there. Each channel is providing 1 megabit per second to 2 megabit per second. Bandwidth allocation, it all is correlated with the bandwidth allocation by various regulation authorities. Each channel bandwidth 5 megahertz. Encoding scheme is differential binary phase shift keying for 1 megabit per second, and we have differential quadrature phase shift keying for 2 megabit per second using an 11 chip Barker sequence, right? So here we have 802.11 technology, right, by using frequency hopping spread spectrum, multiple channels. So we have to hop the frequency, single hopping between multiple channels based on pseudo noise sequence. That is the pseudo noise sequence we generate. 1 megahertz channels are used, is adjustable, so you can adjust the hopping scheme accordingly. 2.5 hops per second in United States, and 6 megahertz in North America, and 5 megahertz in Japan. So hopping scheme is different in different countries. So 2-level Gaussian FSK modulation, right? So this is the modulation scheme, and here 4-level Gaussian frequency shift keying modulation for 2 megabit per second speed. So here we have infrared, it's omnidirectional. So the 802.11 technology with infrared, range is 20 meter, and 1 megabit per second uses 60 pulse position modulation, right? And 2 megabit per second has each group of 2 data bits, right? Okay. So here is the comparison between infrared and radio transmission. Uses IR diodes, right? So diffuse light is used over there, multiple reflections from walls, from ceilings. And if we talk about the radio, license-free ISM band at 2.4 gigahertz, And here are the advantages of infrared. Simple, the circuitry is simple and cheap. As a result, this is cheaper, and it is available in most of the devices, most of the mobile devices, cell phones, PDAs, laptops, and we don't have to pay for the license, and we can have simple shielding in order to avoid the interference. So here are the advantages of the radio. Wireless LAN and mobile phones can be used, right? So the concepts are the same, as we have seen that most of the modulation schemes or most of the access technology or most of the concepts and the technologies, they are the same. So we can utilize the or you can say reuse the or overload the experience of wireless LAN over there, and coverage of larger area possible, right? And here are the disadvantages for IR: interference by sunlight, heat sources, so very limited license-free frequency band. This is again go for the cost disadvantage over there, low bandwidth if we talk about the infrared, right? And one of the example is infrared data association, many different products. So if we talk about comparison between infrastructure and ad hoc network, so here you can see we have the infrastructure network, right? And you can see we have the backbone, that is the wired infrastructure over here, and those access points, they are connected by this backbone, by this wired infrastructure, right? And within this, if we declare those different circles as cells, right? So for example, this is cell 1, this is cell 2, and here we have cell 3. So it's access point 1, access point 2, and access point 3, right? So you can see that we have different access points in different cells over there, and those access points, they are actually sharing this backbone in order to provide services to the individual cells. So this is the one configuration when we talk about the infrastructure network. So here, because most of the service access, data access is relying on this backbone infrastructure. So over here, you can see that those different ad hoc networks, they can operate at their own, but remember that we need to build some sort of or use some sort of specialized protocol so that they can have the capability to organize and manage by themselves. So as mentioned that when there was a requirement for the wireless standards for wireless SX technologies to be launched, so there were a lot of companies who suddenly jumped into the market, and they started preparing and building, designing, developing their non-standardized equipment, or you can say they were using their own standards. So in response to this, IEEE 802.802 group was developed, and then they developed the first internationally recognized wireless LAN standard that was named IEEE 802.11, and it was published in 1997 after enormous work of 7 years. Well, that was actually the most prominent specification for wireless LANs. Scope of IEEE 802.11 is limited to physical. So the focal area is physical layer and the data link layer. Right? So here are some of the benefits. Of course, different vendors, they have the interoperability, and when you are following certain rules, right, then your procedures are refined after some time, and your development speed improves. So as a result of this standardization, the vendors, they have the fast product development, stable future migration. So if somebody is going to increase the data rate, so it has to be backward compatible. So For example, if we are going to move from 1 megabit per second to 2 megabit per second, so your device should be capable of handling the 1 megabit stream also. So of course, as a result, prices are reduced. Takes into account the following significant differences between wireless and wired LANs: power management, that is the key issue, security, and the data rate that is correlated with the bandwidth. So here we have shown the IEEE 802 LAN standards family. You can see the focus is on data link layer and the physical layer. So here we have IEEE 802.3 carrier sense and IEEE 802.4. It is using token bus, token ring, and here we have the wireless access over here. And if we talk about 802.2 logical link control LLC over here, and here is the protocol stack. You can see that we have physical layer, and over physical layer we have different technologies that are being used, and then above that we have the MAC layer or data link layer, and above we have the upper layer. So you can see that different technologies that are being used. For example, if we start from here, 802.11 infrared, frequency hopping spectrum, and we have direct sequence spectrum, right? OFDM and HRDS direct sequence spectrum, and OFDM again. Okay, so here is another technology that is again the newest technology, Li-Fi, the transmission of data without wires from one point to another point, right? So it's again the wireless communication. Data through illumination by taking the fiber out of fiber optics, by sending data through LED light bulb that varies in intensity faster than the human eye can follow, right? So it is again invisible for human eye. Some have used to label the fast and cheap wireless communication system, which is the optical version of Wi-Fi. You can say this in Wi-Fi we are actually relying on electromagnetic radiations. So over here again this is the wireless communication, but here we are relying on the optics, right? The term was first used in this context by Hess in his TED talk. At the heart of this technology is a new generation of high brightness light emitting diodes, right? So we are using, so here is the infrastructure for Li-Fi solid state plasma lighting, right? So you can see that we have different LEDs, light emitting diodes, and they are configured accordingly. And here is the comparison between current and future wireless technologies when we are talking about Li-Fi. So if we talk about, here we have the technology, speed, right? Wi-Fi 802.11n, 150 megabit per second, Bluetooth 3 megabit per second. And then if we talk about the future technologies, these are the current technologies that are being used. WiGig, 2 gigabit per second. Then we have Giga IR, 1 gigabit per second, Li-Fi 1 gigabit per second. So here we have the technologies which are being used and the future technologies and their data rate. So here we are going to finish the first part of this lecture, and this first part we talked about wireless LAN applications, the requirements for wireless LANs, and then we have classified different wireless LANs according to the techniques that are being used. We talked about direct sequence spectrum and frequency hopping technique that is being used in wireless LANs, IEEE standardization 802.11, and then we compared different technologies, and lastly we talked about 802.11 protocol. So here comes the second part of the lecture. We will be talking about the GNG radio, that is a software defined radio, and we have discussed software defined radio in one of our previous lectures. So these are the bullet points which we will be going through. What is GNG radio, basic concepts, architecture of GNG radio, and the scripting language Python. And then we have an example. So it's actually a software toolkit, and what it is doing, it is actually performing digital signal processing tasks that are performed by using ASICs, specialized hardware, software radio construction, rapid development. This development is very fast because there are a lot of already ready to use libraries that we can use. For example, if I have to use an IIR filter, right, so it's already there. I just have to change certain parameters and I will be able to use that filter. If I want to use some modulation scheme, so the code is there, I just have to change the parameters, or maybe we can also use the blocks, right? We can just drop, select and drop the block into this box and connect them. So the development is very rapid. We can construct cognitive radios, and there is a specialized hardware that we can use in order to emulate, in order to test our environment or test our use case for maybe wireless communication, or maybe if we want to test some LTE protocol, or maybe we want to test the communication that has to be performed by using GSM infrastructure. So we can use this universal software radio peripheral, that is the specialized hardware, in order to use with this GNU radio, that is software defined radio. Right, so it will be acting as a hardware front end for sending and receiving data waveforms. So here is the components. We have the RF front end. This is the antenna, and here we have high-speed A to D D2A converters for digital front end in order to use USRP over this infrastructure. So the data then goes to the host computer, and here is the GNG radio that is performing or replacing the rigid sort of circuitry. It's an open source software, right? And we can have a lot of different tools, a lot of different classes, a lot of different functions that are available. We can have 802.11b, ZigBee, right? And we also have some modulation schemes, OFDM, differential binary phase shift keying, and these are the features of this GNG radio software. We have extensive library, right? And actually there are different functions, right? So there are different, you can say, blocks that are available in GNG radio. So there are few requirements. First, how to join those different blocks, right? And whenever we have to join those different blocks, so how to change the parameters. So whenever we talk about the modulation, so we have to specify certain parameters. We talk about the filters, we have to specify certain parameters. So we need a scripting language so that we will be able to manage those configurations. So Python is actually gluing all or handling all this requirement. This is actually plotting the flow graph, right, and gluing all those different blocks together in order to have the functionality. So here are the hardware that can be used and its feature, right? So we have USRP front end. So within the USRP we have different daughter boards, and those daughter boards, they have different frequency bands or they support different frequency bands, right? So we have to mount different daughter boards in order to have support for different frequency bands. So this is the schematic, right? So we have the daughter board, and then we have high speed A to D and D2A converters, and then FPGA, and this is the USB interface. But nowadays with the latest USRP kits, we have the interfacing by the Ethernet, that is the high speed Ethernet, so that we can send and receive data to the host computer at a faster speed, right? And here we have some of the basic blocks, signal processing blocks, right? It can accept the input, and it also have the output stream. We have the source, right? So it is actually generating different signals. We can also generate noise, right? Some other signals, and then we have sinks. So sinks don't have any output because the data has to be synced there. So you can see different blocks over there, right? And then we have data streams, right? So operate on streams of data. So here are some of the data types. We have short, character, int, float, complex, vector, input signatures, right? Output signatures. And we can also generate flow graphs by using GNU radio. So you can see that data stream flowing from source to sink, right? So here we have this signal source, here is the noise, and here we have the sink. And here is the architecture of the GNU radio, right? So user-defined code, right? GNU radio. Useful APIs, we can use some of APIs, and this is the motherboard or USRP kit. This is the daughter board, and this is the host computer. So we can have, we can develop our own function in order to add new functionality within the GNU radio, right? And this is the daughter board. So if I want to work in GSM, so I need a quad band 900 to 1800 megahertz front end. So I will be mounting the daughter board accordingly, and I should be having the antenna accordingly, for example vertex 900, right? So this is the actually architecture D2A. If we talk about transmission, when we talk about the reception, so should be A to D, right? Signal processing blocks and flow graphs that are actually written in C++, right? So for composing blocks, joining and then configuring different parameters. So here is glue to connect modules, right? So here we don't need performance, so we just have to configure, right? So here performance is important, so that's why we are using C++ over here. So you can see scheduler, control flow graph, right? C++, the core, and then the Python. So this framework is for scheduling and control flow. This is provided by the SWIG, right? So here you can see we have different functions that are written in C++. And we also have another graphical front end, that is GNU Radio Companion, GRC, right? So we can have GRC files. So you can see we just have to choose the block and pick, select, and drop it. Then we can change certain properties of the block. For example, if you look over here, so it's a random source over here, right? So number sync, FFT sync. So we have a lot of different blocks that are available over there. So here is the GRC, GNU Radio Companion, design flow graph, right? So we can perform different demonstrations. So you can have built-in examples within GNU Radio there, right? So for example, here we have the dial tone example, sine generator, and here is the sine wave generator at 440 hertz. And this is the audio sync, right? So here is the code for dial tone example. So that's all for the second part of the lecture. So in this part, we have talked about GNU radio, that is a software-defined radio. We talked about the architecture of the underlying GNU radio, and there are a lot of different examples, and you can try it yourself. It's very easy. You can just use Ubuntu, because this is actually developed natively for Linux. We can also use it on Mac OS X, right? So for the Windows, I'm not sure, but you can install it easily. It's very easy to use it. You just have to use, for example, if you're working on Ubuntu, so you just can use the Software Center or maybe Synaptic in order to install. So all the dependencies and libraries will be installed by themselves, so you don't have to go into more complications. So you can test and there are a lot of different built-in examples. You can at least run those examples and you can see that how it is working. So that's all for today's lecture. आज के लिए इतना ही काफ़ी है. मेरी तरफ से अस्सलाम वालेकुम. अपना ख्याल रखिएगा. अल्लाह हाफिज़.